Ladies and gentlemen, this is Joe's Classic Video Games back with another cool pinball repair video for you this evening. We have been working on this Williams Black Knight pinball machine. Look how cool. Look how great. A customer brought us this in. This one actually is from Wales. It made it all the way over here to South Carolina. How's about that? The gentleman that owns it was in the Air Force. He bought it in Wales and then flew home with it. So we did a couple videos on it already, and we've been working through it, and unfortunately we've ran into all kinds of problems on the CPU, but we think we've got it up and running now. It's running the test EEPROM, it's blinking, it's doing its thing, it's outputting on all the PIAs. We had to replace nearly every chip on the board. It looks like at some point someone may have plugged all the wires in backwards. So see how there is a big huge black connector here? And then there is a big huge white connector here. They're the same size. So you could plug them into the wrong one. Now one's black, one set's black, one set's white. But I've heard that sometimes at the factory they mix them up. So one might, on some games you might want a black one into a white one or whatever. It just, you have to watch the wire colors. So see how you have orange here and orange there. Just make sure that the wires pass through. So I think that someone may have plugged it in backwards at some point in its life and screwed up all kinds of stuff. In the previous video, if you didn't see that, whenever we turned it on, smoke rolled out of one of the chips that apparently had been fried because of that. IC7, which was this little baby. I later figured out that it does the same thing with IC5, which is this little baby. Basically the switches on the coin door, if you plug those in backwards, you send flipper voltage through the switches into the onto the board, and it connects to a couple ICs, and it fries those two ICs. We also had this chip here that runs the display was messed up. We had a chip over here that runs the LED that was messed up. We had a chip here that runs the diagnostic button that was messed up. Here come the police. There they went. I didn't do it. Hope they find whoever it is. The EEPROM, the socket was messed up. I had to replace that. Two of the buffers didn't work on the address lines. I don't know. Swap those. Swap the third one of the same type just for giggles. Also swapped the data bus because we were having trouble and couldn't figure out what was going on. One of the RAM was bad. Took us a while to figure that out. The test EEPROM wouldn't boot because one of the RAM was bad. The 5101 was also bad. The PIA was not bad, but we put it in a socket because we were testing things. And there were two more over here that we replaced for various other reasons. But we replaced the 555 timer because we thought it was holding down the blinking signal, but then we figured out that it was this driver chip. So we've almost replaced every board on the CPU, and I think it works. I think everything's working on it. With this test EEPROM, basically, it makes all of the outputs of the PIAs toggle. PIA means Peripheral Interface Adapter. So this one is used for the displays and for that LED. This one is used for the soundboard and things like that. And then our next step is the driver board that goes down here also has some PIAs on it. One for the lamps, one for the switch, maybe not the switches. One for the lamps, one for the coils, and yeah, one for the switches. So we need to test those. So with this test chip in it, we can put that board on and test all of those too. Now if you're doing it in the game like this, you need to make sure everything's unplugged except for the power connections. Because if the power is turned on, as that cycles through, it would pulse all of the coils and turn on all the coils and turn on all of the lamps, which would fry all the lamps because the lamps run on a strobe, so they run at 18 volts, but it's strobes, so they only get 6 volts as it strobes through. Well, if it would send full 18 volts to the bulbs, it'd blow out every bulb in the game. So you don't want to do that. So we're going to put the driver board in, but we're not going to plug anything up to it. It's just going to have the power running through here. Now on our previous video, we worked on the driver board just a little bit. All I did was I cleaned the two PIA chips that were in the sockets there. and I replaced the female part of the 40 pin interconnector there. It's a very clean looking board. Everything looks cool. A lot of times you'll see one of these transistors all burn up. Nothing like that on this one. It's been serviced before because somebody has put new resistors on it. So we're going to pop it in and see what kind of result we get. So I'm going to turn it off, snap it on there, put a couple screws in it to hold it in place, and then we'll see if it boots up and then if these PIA chips are doing their pulsing like they're supposed to. Okay, so you can test them the same way that we tested the ones on the CPU. So now that we've got it mounted in there, it's up and running. You're just looking at the outputs of the PIA chips. So this one does the solenoids. And you just go through the outputs. They're all listed in the manual. It's basically pins 2 through 17. And if the outputs are working, well then you know that the inputs are pretty much working and blah, 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 right? So this is the solenoid one. It seems to be fine. This is the lamp one. It seems to be fine. If those two connections are plugged in backwards, it seems that it sends power down the switch lines. And it's as simple as just looking in the manual and trying to figure out, okay, power is coming from the board out the connector this way to the playfield, but if they put the wrong wire, it would connect to this, which would maybe connect through the coils back to the board. And if you look, it looks like it sends solenoid voltage in on the switches. Okay, so we're going to do the same thing with this PIA. I'm going to start at this end though, just because these you have to do something special. Checking temperature. 20, 19, 18, 17. So number 17, you see is pulsing. 16 is pulsing. 15 is pulsing. 14 is pulsing. 13, 12, 11 acting weird. 10 stuck low. So now you got a chicken and an egg scenario. Is it this chip or is it this chip? Because those lines there connect to this, these lines here connect to this. So the power came back through, it would have hit these chips first. If you look at the schematics, this chip gets hit by the power if you were to connect the wires backwards. So another way you can check it is at the edge connector. So these are the lines sending out to the switch rows. You see everything's cool. Now we're not cool. So we know at a minimum that this chip is messed up because we saw at least 2 of the signals are going to it. And then one is stuck low and the other one is doing some weird floating thing. So the first thing we're going to do is replace this. It could be though that the PIA is bad too. So the other thing that you can check is pins 2 through 9, like we did on the other ones. But if you check them, you get nothing. That's because they're inputs. And we don't have anything plugged in right now. Okay, so a little trick you can do is you can take a jumper, hook it to ground, and then you're going to short ground to an input. So we just grounded a switch basically. And now it's working. But if you go to the next pin, it's not, because it's not grounded. And you can short these all together because you're just shorting them to ground and their inputs. So if you go through, basically all of them are working. So hopefully the PIA is fine. Now why do I say hopefully? Because it's a 40 pin chip and I don't want to swap it. Takes forever. Someone already has, but it was soldered into the board, which means it might take more forever now. But I think it seems to me like we just tested those chips by sending a signal, a ground to them. It works back through them and has this doing its thing. So it seems like they're fine. It seems like this one's fine. We got a couple questionable outputs right here on pin 10 and 11 that run into this. And then this isn't doing any outputs. So this is number 1. That's the first one we want to try. And it seems like the other two are working fine. And if the thing gets plugged in backwards, it doesn't seem like it sends power to anything on the solenoid section that would screw anything up, or the lamp section that would screw anything up. I'm not positive exactly how that works, but the lamp section runs off 18 volts, so it may be that just since it's more robust, it can handle it. The solenoid section, if you're sending 28 volts to it, that's what it handles usually anyway, so it probably wouldn't screw it up. I guess you could get through the transistors back to the buffers and screw it up or something, but whatever. And then the other thing that it does is, if you plug it in wrong, is it sends flipper voltage to this soundboard. And it just sends it right through the speaker wires. So instead of the speaker being plugged in where it's supposed to be, if you swap the two connectors accidentally, you send power back through the speaker wires. You're sending 28 volts to both sides of the sound amp. So whenever we got it, we haven't heard a peep out of it the whole time. Probably because the sound amp's fried. Probably because the two connectors were swapped at some point. I took out the MPU chip and tried it over here when I was swapping things, trying to see what was what. But we still got it, and we can put it back in. But we'll mess with that later. We got to check this driver board first, though. So I think everything's cool, except for this chip, which I believe is IC17. So I'm going to pop it out and swap that sucker. And it is a, well, I don't know what it is. Man, you can't hardly read some of these schematics. It's a 7406. I got that. I got one of those. Let me go swap it. All right, we swapped in a nice new chip, 7406. Let's check it out. The top 4 are the top chip. So here's our new chip. This is the one that was stuck high. Another one that was stuck high. Another one that was stuck high. Boom, 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 boom. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's still doing its zany thing. And number 11. No, 10 was just stuck low before, and then now this is what 11 was doing. Okay, so what happened there? Well, we had 2 that were screwed up because of that chip, and then the other 2 were screwed up because of this chip. So I got to replace the PIA. I want you to notice it's the only one that isn't in a socket. It's harder that way. Okay, so I swapped it out, put a socket in. Now, if we go to the ones that we were having problems with, they are now pulsing. I forgot to mention, when I took this one out, it did have a hole blown in the bottom of it. All right, so all 3 PIAs seem to be doing their thing. There's further tests you can do. You can check the lights and see if they're pulsing all the way through all the things. You can check all the solenoids and see if they're pulsing through all the things, but you have to do a bunch of specific tests and everything. And it's cool that it's like that because you can test it all on the bench, but we're sitting here in the pinball machine, so I'm just going to test it whenever we get the game up and running, you know. And plus, I really do believe that what happened was those connectors got swapped, which would have caused problems here. It wouldn't have, hopefully, caused any problems with the lamps or the solenoids. So I think what that means is we're about ready to make it back into a pinball board. So to do that, I need to remove this ROM and reinstall the 4 original ROMs and then see if it'll boot up. And I'm going to do that with everything still unplugged. It will boot with just the power connector over there. You don't need all this other stuff to get it to come up. So we'll try that. Okay, folks, so we put the 4 ROMs back in where they go. So now it thinks it's a pinball machine again instead of a test bed. So let's turn it on and see what happens. So the 0 came on, went back off. That's good. and we heard the flipper relay energize and go back. Well, I guess it just stayed on. So that's good. So we're going to turn it off. So I think the board's probably working. So I'm going to put the rest of the screws back in it. And then we're going to plug up the lamps. I think we'll try that first. So if it is in attract mode, we need to see if some lights will work. So I'm going to plug up the lamp connectors down there at the bottom. I'm going to put the rest of the screws back in it just to make sure it's all grounded out like it's supposed to be. And then we'll try it with just the lamps on. Okay, so I put all the screws back in. It's important on these to have all of the screws in it because that's how it gets its ground, or a lot of the ground. And also, you get, sometimes you'll get coils will stick on and weird stuff like that if the boards aren't grounded right, and you'll get like a hum on the soundboard and a bunch of stuff. So just put all your screws in there, people. Okay, so we've got the lamp stuff plugged in. I'm just doing that because basically the things that I don't like plugging in are the displays because they run off of 200 volts. That's a lot of juice. Now the thing's already got the power to the thing, the board's plugged in, but they're not plugged into the MPU right now. But it runs off of 100 and the negative 100. This particular game doesn't even have any displays in it yet. They're waiting for us right there. So I usually try to keep the displays not plugged in. Plus we don't have them in the game. And then also the solenoids, you know, the voltage is a little higher on those. And if one locks on, you can see some explosive stuff there. So the least intrusive one to me seems to be the lights. Now you can plug in the switches, but then how would you know if the game is on? Basically we're trying to tell if the thing is actually coming on, right? So since we don't have any displays, we can't see anything on them. So let's turn it on. Okay, so again, the LED came on 0 and then it went off. That's how it's supposed to be. But look, we don't have anything going on, but we plugged all the lights in. But what's probably going on is we don't have the battery plugged up. So they've moved the battery off the MPU over to the side so that if it starts dripping acid or whatever, it won't rot out the board. It'll all drip down over there and be less of a mess. So since there's no batteries, it's probably in test mode, the bookkeeping mode. So there is a trick on the old Williams. If you get one, if there was a display, it would be saying the version number of the game in one of these displays. And so it's like the checksum of the ROM or the release number of the game or something like that. It usually says something like 024367 or something like that, if I remember correctly. So my theory is that that's what it's doing right now. But we can't tell because the display's not in there. So if you do have one where the batteries are dead or they're out of it or something like that, and it boots up with this weird number on the display, that's what's going on. It's in test mode. So the way you can kind of trick it past that is if you turn the game off and then right back on really quick, it kind of jumps over the voltage because it doesn't have enough time to drain out of the caps. That looks like a Black Knight pinball machine that's up and running. Let's see what they look like in the dark. It looks like this one's going to have a really nice light show. Very cool. Boy, I love it. I don't believe those are LEDs. Those are the original bulbs, I believe. They look too good. So yeah, I think we're up and running. All right, so next we'll plug in the solenoids and we'll plug in the switches and we'll see if the game will actually start. Okay, so I put three new balls in it. I put some batteries in the battery holder and hooked it up too. Boy, it's got a cool attract mode. What's up with that? I put batteries in it too so that it won't come up in test mode that we think it's in. And let's see if it'll start. Yeah, baby. Okay. So we got a little problem here where the ball sticks on the switch. So that needs a little adjustment. But it reset the drop targets. And the two up there. Left flippers work. One right flipper works. That's pretty good though. Let's see if it'll score anything or if it looks like it's scoring anything. We landed up in there, but it doesn't like it. We got a little bit of points. So. Well, we got a little bit of issues going on. It's trying at least. Targets down, spots the arrow. Unfortunately, the drop targets on these are kind of not the greatest. Pop bumper's working. It about bit me. You saw what it did. You saw what it did. It doesn't know the ball's in there, so it's got a switch issue. But that's cool. We appear to be playing a game, though. It's just we got a bunch of switches that aren't really doing what they need to do. We haven't messed with any of that yet. Okay, well, we're up and running. This is all stuff that needs to be messed with. We can do that later, though. I kind of want to get the displays working so we can see what we've got going on. Let me. So we still got the displays, we've still got the soundboard, and then we've got to work on playfield stuff like switches and the flipper that's not working, etc., etc., which will also be a switch problem, I'm sure. This light bulb's burnt out, but it looks like everything's pretty cool. Okay, so let's look in the box and see what we've got in the way of displays. Here is what's in the box. We've got a whole stack of display stuff here. Pin score LED display for Williams System 6A, 7, and 9. Okay, so Black Knight is a Williams System 7, which is actually very similar to the 6. I think it was the first System 7 game. Good old Steve Ritchie pushing the barrier there. He pushed them from 6 to 7. But it's still got a lot of the System 6 stuff. So like the power supply is from a System 6 instead of the later System 7 power supply, blah, blah, blah. So it's kind of in the middle, but the CPU is System 7. Overview. Brilliant design makes brilliant displays. Let me get where we can read it. New pin score LED displays for pinball machines are the best performing, most feature-packed, and economical replacement systems for obsolete glass plasma digital displays. Well, that's exactly what we need. Features: plug-and-play installation, no soldering required. Low power consumption. Adjustable, flicker-free brightness control. That's right, people, it's flicker-free. Self-test diagnostic button. 5-volt powered, no high voltage required. That's right, people. 5-volt powered, no high voltage required. Black matte finish. 5-year warranty. Lead-free, RoHS compliant. You know, should I say something about that? Let me rethink that. Made in the USA. I was just going to say, you know, that doesn't mean anything to me. But there's probably people out there that's a very important feature to them. They may have had some problems with some lead. Supported games. This pin score system model PF8363P will work in the following Williams pinball machines. Oh, by the way, whenever somebody was mentioning whenever I do that, the lisp, that I was making fun of somebody, I am not. I'm doing that because I'm imitating Sylvester. Sylvester was one of my childhood formative teachers. I saw him every day. Will work in the following Williams pinball machines: Algar, Alien Poker, Barracora, Black Knight, Comet for driver boards with card edge connectors. Cosmic Gunfight, Firepower 2, Jungle Lord, Laser Q, Pharaoh, Solar Fire, Sorcerer, Space Shuttle, Starlight, Time Fantasy, and Warlock. Interesting. You know, I'm looking at that list there of all those Williams games, and you know, a lot of those you don't see very often. What's up with that? They must have not sold as many. The Bally's, I guess the Bally's that we're used to are a little earlier than that. So maybe a lot of these came out in the crash, since it was System 6, 7, and 9. During production of these Williams System 9 games, both the blah, 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 blah. All right, we get all that. Kit contents. Master display, 4 7-digit slave displays, a 4-digit numeric ball credit slave display, 4 foam light shields, and 1 foam light shield for a 4-digit display. That's pretty cool. It utilizes the original ribbon cables in the game. In the event of damaged or missing cables, replacement cables are available for purchase from Pin Score distributors. I think they're hanging in the game because the master board is still in there. Specifications. Operation voltage 5 volts, average current, maximum brightness 140 milliamps, maximum current draw, all segments lit 190 milliamps, average power, maximum brightness 0.7 watts, maximum power, all segments lit 0.95 watts. Don't use much, people. Okay, the LED displays are powered from the game's 5-volt power supply and require no high voltage. LED displays use nearly half the power of competitive LED displays, making them safe to add to your game. Pin Score displays have been tested in all games and are known to work reliably. In very rare cases, a game with a failing 5-volt power supply may not function once a Pin Score display is installed. Other symptoms of a failing power supply include erratic game resets and erratic game behavior. In these situations, the game's power supply should be repaired or replaced prior to installing the LED displays. Now, on this power supply, I did replace the 5-volt filter capacitor and the 2 diodes that rectify it. So, hopefully we're good there. I'm getting a nice strong 5.05 on the CPU. That's what you want. You want it to hit the CPU just a little bit above 5. That way, if it gets lower down here, you're still at 5 over on the other side of the board. That's your best situation. The plasma technology found in your machine's old displays required high voltage to energize the segments. The high voltage circuits in pinball machines have high failure rates and are difficult to repair as the parts are obsolete. LED displays will function correctly even if your original game's high voltage power supply has failed. You can choose to disable your high voltage supply after installing these displays by removing the appropriate fusing. See your machine's documentation. This will reduce the risk of electric shock when servicing the machine. If your machine requires a new power supply, Pin Score power supplies designed specifically for LED displays are available for many games. Oh, that's pretty cool. I did not realize that. They make a power supply without the high voltage section. That's kind of neat. Huh. That's a pretty good idea, actually. I'll have to look into that. I usually rebuild the original power supply because, yeah, it's kind of complex, I guess, slightly, and some of the parts are obsolete, but it can be done, and I've got a bunch of the parts, so I rebuild them all the time. But if you're if you want to buy a new one and put in a new board, it's kind of a waste to buy one with a high voltage section if you're going to use LED displays. So if you could buy one that didn't have the high voltage section and save a little money, that's kind of cool. I like that. This display system cannot be used with any original display or driver boards. Damage to both the new and old boards will occur if the systems are mixed. Please remove all original boards and install Only these new boards. That's very important, people. If you're not listening to me because I've been joking around, wake up, wake up. You have to use the entire new system. It may seem, it may seem like, oh, well, I've only got 2 displays out. Let me just plug in 2 of these LED displays to replace those 2. You can't do that on the Williams games. You can on the Bally ones on some systems. So, but on the Williams, because of the way they work, you can't do that. So you can't just buy 1 or 2 or buy a set and only use 1 or 2. It will fry everything. It will fry the new board. It may fry the old board. It may fry your old master display board, and it may screw up your CPU. Do not do that. Very, very bad to mix the displays. Unplug the AC power from your pinball machine. Remove the game back glass. Unscrew and remove all original glass displays, master driver board, and all inter-board connecting cables. Mount all new boards in their respective locations and only hand tighten the mounting screws. You may slide the LED display boards horizontally to adjust their positions for alignment with your back glass windows. If not already in place, place the foam light shields on their respective LED display boards. Connect the cables. Observe correct polarity on all ribbon cables. The red striped wire on all ribbon cables goes to pin number 1 on all boards. Double check all connections, plug in the machine, and turn the game on. The LEDs will light up. Pressing the diagnostic push button on the master driver board will illuminate all segments of all displays. This indicates that all boards and cables in the pin score system are operating correctly. Use the thumb wheel brightness control on the master driver board to set your preferred illumination level. I'll tell you my preferred. All the way live, baby. Play pinball. You'll enjoy your pin score displays for years to come. Somebody responded on one of our videos that they figured out the life of the LEDs. They said they do wear out and that they lose, I think they said 50% of their brightness over 40 years if they're operated at maximum, if they're operated at maximum current. Like, did the math on it, right? But that's if every segment's lit up constantly, and they're not because they're strobed. That's just not how they work. You don't light those up constantly. They're flickering. It's just faster than your eye can see. So they're not running at full juice, even if you turn that wheel all the way up. And if they were running at full juice, you'd only lose half of the brightness over 40 years. So are you going to stand around with a dim display for 40 freaking years so that you can, what the hell? You might be dead by then. Hopefully I won't be. Let's not even go there, but you might be. You might be dead by then. So you know what I'm going to do? I'm going to turn them all the way up, and I'm going to enjoy the next 40 years. Warranty. All pin score display products are covered by a 2-year non-transferable warranty. Okay, so they're warranted. I wish the autofocus on my camera was warranted. Alright, so we're going to go take the old master board out, and we're going to slowly put in the new stuff, and we'll see how these suckers work. So here's the old master display board. Very cool. Plasmas no more. We have put the new one in. They just mount with these little 1/4-inch studs. Hooked everything up. And I only hooked up one display for now, just in case we fry everything. No use frying all 4 of them, all 5 of them. And then over here, I took out the high voltage fuse, because that will kill the high voltage area of the power supply, and it'll no longer be used. Okay, so here we go. We're going to try it. Let's see what happens. I hope it works. Boy, that'd be cool if it did. Look for smoke. We're looking for smoke, people. Now, if you've seen the earlier video, you know that's not that funny. We burn up a chip on an earlier video. I see no smoke, though. It looks like we might be good. But if you watch the earlier video, whenever we worked on the CPU, the MPU, we replaced like 10 chips or something. Found all kinds of stuff messed up. It's doing something. I think we're in test mode. See, look at that brightness. That ain't bright enough. Much better. You guys can't see it that good. Let me darken it up so you can see what I'm seeing. That's not what I'm seeing. That's about how it looks right now. Okay, so we're in test mode, I think. Yeah. So it's going through the test settings. Eventually we'll get all the way through and it'll go into a track mode. These are just setting numbers. Not sure what that is. I guess more settings. We may eventually get through it. Well, am I going backwards and that's the whole problem? I think the whole problem is I was going backwards. Oh, I went too far that time. One more time. If you go backwards through the audits, I think I did it again. Well, kind of looks like we're in a track, but how come I don't have any lights on the playfield? Oh, you kidding me? Did I take out the wrong fuse? Maybe I took out the wrong fuse. Let me go check. Well, that's more like it. It's very confusing because on this little cheat sheet over here, it shows a fuse that doesn't exist. I don't know why they did that. I have yet to figure it out. I guess the fuse originally went right there, but then they stopped putting it on the boards at some point, but they left it on the drawing. So they redesigned the entire, like the way the electronics work and the fuses work, but they didn't redesign the freaking piece of paper that they put in the back box. I don't know, I've never understood that. Whatever. That's more like it. So we're in a track, got all our lights on. Okay, so let me pop in the other ones, and then maybe we'll finally be able to see something. All right. So we got that taken care of. I can't get it to look on the camera exactly like it looks here in person, but it looks really good. Okay, so the last major thing we've got left is that soundboard. It's completely dead, hasn't made a peep yet. But if our theory is right that they swapped the connectors, it would have sent 28 volts to the sound amp on the ground side and the speaker side. So, but that would be the only thing that it shorted on the ground on the soundboard. It's just basically it would have sent the power, the solenoid voltage down the speaker wires, not to the speaker. The speaker would be disconnected. It'd be sending the speaker wires connected to the soundboard. So we'll pull that out. There's a cap in line there too, so maybe that cap will have some damage that we can tell. We'll just do the typical stuff like clean it up. So here's our soundboard, and here's the schematic. So our theory is voltage went in here and here. Be 28 volts or something like that going in here. So one side just connects directly to ground, so that shouldn't have really, I mean, it would have caused problems. So it would have went in here and connected directly to ground. It would have caused problems, but I don't know that it would have caused any problems on the board. And then the other would have plugged in here, where the 1 and 2 is. Okay, and it runs directly into this capacitor, C14. So C14 is this big 1,000 microfarad capacitor, 16 volt. On the schematics it says it's an 800 actually, so they were just, I guess, using what they had handy. So I'm going to check these resistors around here, and then just for giggles, I'm going to replace just that one cap and see if that does anything. I don't think it will. I don't know if it will. Well, I don't know that it was DC voltage. It wouldn't have been AC. It would have been DC. So I don't know if it would have fried that capacitor or not. But we're not getting any sound, so something's going on. So I think what we'll do is we'll replace that, and then I might pull the sound amp and then just check it against a new one and see how it measures with the multimeter. There's the sound amp there. But I think I'll do just the one cap first and pop it back in and see if that changes anything. Okay, folks, so that cap didn't fix anything. We were just doing that just for giggles. So now we're back to the drawing board. So we're going to ignore up there for now and check the power first. So if I check the power, both of these fuses are fine. Okay, that's right here. Now this is it's almost 20 volts that it's getting from the transformer down in the bottom, AC. And it runs right into this bridge rectifier. And then in the game, if you test the voltage over here, you do not get your 5 volts that you have. So this is the ground, which is also, by the way, tied to the whole edge of the board and the back box and everything's all tied together. So your grounds are all together. But if you test point 4, there is no 5 volts. So then you move backwards. If you test point 1, there is no 12 volts. And if you test point 2, you do have a negative 12 volts DC. So the power is here. You got 20 volts on this side of both of the fuses, and there is 20 volts on both sides of these fuses, and on these sides of the fuses, which means that you're getting 20 volts to your bridge, but you're not getting 12 out. Now, a bridge rectifier, this particular one is just a rectangular type, the old school type. Bridge rectifier is really just 4 diodes inside. So you can test it just like you would test a diode. So if I take you see the arrow is the direction that voltage can flow, right? So if I check from pin 3 with my red lead to pin 1 with my black lead, it's not connected at all. That diode's bad. If I connect from pin 2 to pin 1, it's not connected at all. That diode's bad. If I connect from pin 3 to pin 4, it's not connected at all. That diode's bad. But this diode seems fine. Now, I don't think they could have done this with plugging it in backwards. This is just this bridge rectifier has died. So this diode, this one connection is the only part of it that's working, which somehow is giving us 12 volts. I guess that could be half-wave rectification or something. I don't know. I don't know how that works. But so this bridge I'm going to have to replace first to get our 12 volts and then see if our voltage regulator here can give us our 5 volts. So that's why it's not working. It doesn't have any of the voltages. So I'm going to pop out that little square or rectangular bridge, and then we'll pop in a new one. Okay, I swapped it out. The one I put in is a little bigger, but that won't hurt nothing. And then I confirmed by testing the legs outside that there's only a connection between 2 of the diodes. So to check it, you just put it on diode test, and where the positive is, you put your negative lead and then check the 2 AC lines. You should see between 0.4 and 0.7 or so voltage drop. And then this is the negative down here. You put your positive lead where the negative is and then check between the AC lines. And you should see between 0.4 and 0.7 on each one of those. So on this one, I've got 1 doing that, and the other 3 are open. So this bridge rectifier has just failed catastrophically. I don't know how 3 of them failed at the same time. So this one I put in is more beefy, so it's a little bit bigger. But it'll be okay. Bigger's always better, right? Let's go slide it back in the machine and see if that changed anything. Okay, folks, so put it back in. We are now getting a big, nice hum whenever it comes on. And then if you touch the amp, you get a buzz, which is usually a good sign that the amp's good. If I hit the test button, it waits a few seconds, and then it starts talking. The Black Knight has risen. He's talking to me, but it's not playing any of the sounds. So this board does the sounds, and then the little board that's over here does the speech, right? So the speech board's working, but this board still has problems. But the way that it can tell that the button was hit is the CPU's running, the PIA is running, blah, 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 blah. right? So a lot of it's working. Now, I hooked up a multimeter to it and got something interesting. So whenever you hit the button, blah, 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 it does its thing. And then this PIA starts throwing signals out through here. So it's sending signals to this DAC, a 1408 digital to analog converter. So all of these are pulsing, but only when it's supposed to be making the sounds. So it's supposed to make a few sounds, and then it starts all the speeching, the speeches. Whenever it does the speech, these pulse, and it sends it out this way, right, over to the speech board. Okay. So it tells it to make sound. It sends it to here, which outputs on pin 16. Okay, we've got our negative 12, and we've got our ground down here, right? But all this is supposed to go out, and then it runs through this transistor, 2N4401. It tests fine, but I replaced it anyway. And then it runs through this capacitor, C29. So I swapped it. Boy, don't it look old. So I swapped it, right? So basically, I'm getting pulsing over here going into the DAC. I don't have a way to check the analog output easily. And the logic probe won't check it because it's sound. It's not digital anymore. Okay, and so it outputs it here and blah, 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 blah. And then it comes up to here, and you see that there is a jumper. Well, if that jumper is in there, the sound just goes straight out to the volume control, comes back in the volume control, and goes to the amp. Okay. They had that jumper on there. That jumper is not supposed to be there, though. Someone had added it in. That jumper is to eliminate sending this sound over to the speech board. I know all this may seem real complex, but if you think about it, you'll get what I'm saying. So this board can do sounds. It needs the separate board to do speech. Okay. So if only this board is in here, you put this jumper on so that the output of this chip, which does all of the sounds that this board can do, the output of that chip goes through this jumper, out to the volume control, back through, and over to the sound amp. And then goes out, right? We're getting speech, but we're not getting sounds. And since we have a speech board, we shouldn't have that jumper on there. Someone has added that trying to troubleshoot this board, I think. So that should be gone. So what should happen is the sound that comes out of here should go through here, over all the way this way, blah, 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 and then off the board on this pin 3, which says sound analog. Okay, so it goes off the board and runs over to your speech board. So it comes through this ribbon cable onto the speech board. Okay, it comes in, sound analog input, runs through some stuff, and then runs through this volume pot, sound speech mixer. Now you may have saw that there's a pot about right here on the speech board, so you can turn up the voice versus the sound, the background sounds, right? And so once it does that, it's then mixed with the other stuff, and it goes out as mixed sound speech output, right? So it runs through this 1458, blah 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 blah, and it basically just combines what this board is doing, which is making the speech, basically playing samples, or I guess this 55516 is doing it, right? So the ROMs, the 55516, and then it outputs, blah, 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 does the thing, right? Where does it get its signal from? Yeah, the output right there. So it comes through here, and it mixes the sound, the speech, and the background sounds together, and then sends them combined as mixed sound speech output back across the ribbon cable. Okay. So once it pops back across the ribbon cable, it goes as mixed sound speech up this way, up this way, up this way, and goes right back to where the jumper was. Goes out to the volume control, back over, and goes out. So if you put this jumper on, you don't send it off. You don't send the sound off the board because there is no speech board. So that jumper is so that this is the only sound there is. If you take that jumper out, then this goes through the other board so that you can adjust the volume potentiometer over there to mix the sound and the speech, right? So why was there a jumper there? It's because this wasn't working. So they were thinking, is the problem the ribbon cable? Because it could be that it's sending it out on the line, but the ribbon cable's not good. So if you put that jumper, you're just kind of shortcutting it. You lose your ability to adjust the volume, but you're sending the analog sound that this is making out, and also the speech is coming over and going out. Well, I'm getting speech, but I'm not getting the analog sound. So I think they were putting that on there to just make sure that it wasn't the line or something on the speech board that was screwing it up, right? So I've replaced this, and I've replaced this cap. And now we're going to try it again just to see if that had anything to do with it. If that didn't have anything to do with it, it's probably the chip itself, the DAC. That's what I would guess, at least. It's a 1408. I don't know if I've got any new ones of those, but I've probably got used ones on other boards that I could pop off and try on it. So we'll pop it back in the game and see if we get anything different. Okay, folks, so we got it back in there. There's the ribbon cable I was talking about. There is the adjustment that I was talking about to mix the speech and the sound. Okay, so again, I replaced one capacitor. It's a 10 microfarad, and that also that 2N4401 that it looks like the stuff ran through. So let's see if that got us anywhere. You heard the hum at the beginning. It's telling you there's juice running through the speaker. Now if I touch this amp, hear the buzzing? So the amp's working. Okay, so let's hit the test switch, see what we got.
Night black, defend the challenge, thee will you, I again play, cannot self, enemy, one. Night black, defend the challenge, thee will you, I again play, cannot self, enemy, one.
Boy, that's cool. That's so cool! Okay, so the soundboard's working, but we don't know for sure if the MPU can control the soundboard. It's working if I hit the button, so let's try starting a game. Now, whenever we last messed with it, we've got a couple, like there's a ball stuck up there, we got a couple little issues here. But let's see if we try to start a game, if the sound does anything.
Again, the black night.
All right, well, there we go, people. Our sound is working. We still got some playfield issues and stuff we got to mess with, but we'll do that next time. So I think electronically, though, we've got it all working. We'll finish up the other stuff on the next video, and then we'll play it a little bit. So I hope that helps you if you have a soundboard or a speech problem. If you ever have a problem where some of the words are missing, it's usually because one of the ROMs has a bad socket or the ROM needs reburned. But check that line and that cap if you have a problem where you have speech but no sound. That's kind of a weird one. Usually that doesn't happen like that. So there you go. Leave your comments below. Let us know what you think. Make sure to give us a thumbs up for taking the trouble to film it for you. We didn't have to do all that. We didn't have to do that. Come on, people. Make sure to check out our website, too. Go to lionsarcade.com. We've got a list of all of our arcade games and pinball machines and jukeboxes and stuff that we have available for sale right now. Look at this one right here. It needs a little work. This one's going to take a little doing. Old AMI. We have a... I know you want me to go over there and show you the fun house. Yeah, that's the cool one right there. We have a list on our website, lionsarcade.com, of all of the games we have available for sale. Go check it out. Many more to come, though, by the way. And we also have a parts page on there where we have listed some of our stuff that we use whenever we do repairs, tools, and stuff like that. And also stuff like our t-shirts and things like that if you want to support the channel. And finally, don't forget to check out my brother Donnie, who is literally my brother. My brother Donnie has a channel here on YouTube. If you like watching us work on these old pinball machines, you may enjoy Donnie and I working on old buildings. We've bought a couple buildings in a small town near here in their downtown area, and we're trying to fix them up, get some renters in there, and help revitalize downtown. So go check that out, my brother Donnie. But we'll see you one more time with this Black Knight, where we'll try to fix up the rest of the playfield and get it all buttoned up and playable. So I hope you enjoyed it. We'll see you on the next one.